That's up there too. Okay, and that one. Yep. Okay, good. I think that's it. Good evening, everybody. I'm Erik Dalhuijsen, and I'm here to do the first talk, and it's about heat pump installation, which I inadvertently ended up doing in my own house. The talk will, in short, cover the situation, what brought me to that point, a little bit on the design, my idea first to get it installed by someone who knew what they were doing, and why I went for doing it myself, some of the challenges, and how it's working in the end, and a few suggestions. It's quite a lot to cover in 15 minutes, so I'll do my best to make it quick. And if I can get the slides to move, that would be even better. There we go. Yeah, the situation was I had the gas boiler of my house fail in October 2022. Now, my house already had electric showers and a kitchen boiler electric to be able to switch off the gas heating over the summer. So that was kind of convenient. So it was only heating failure, and it didn't kind of stop the hygiene in the house. Because I had experience with gas boiler sellers, because I tried to upgrade my gas boiler about 5-6 years earlier, and had 3 completely incompetent companies quote me really exorbitant amounts for that. So I thought, no, I'm not going to go down that path again. So I'll try to fix it. It needed a new motherboard, so I did that. And then I'll start planning for an air source heat pump. And if I can't fix it, then I'll do the heat pump. I'll find someone to do the heat pump, was the idea. And if it's not fixable, then I'll do that straight away. Just to give you an idea, these are the temperatures, maximum and minimum temperatures, and that little red box is surrounding the temperatures, the outside temperatures during that period. So it was actually the worst winter over the last 3 years. It was just at the beginning of being really cold. And just as I switched on the heat pump several months later was when the temperature increased again. So you'll see what the consequences of that was later. So what I had a cold house, 1960s, poorly built, no insulation other than underfloor and loft insulation. And there's double glazing all around. The house is spread over 3 levels, which is kind of important because that basically means that you get the heat buoyancy. So it disappears from the ground floor where the living room and the kitchen are, and it goes to other places where very little is. I couldn't get cavity wall for various reasons that the council will be able to explain to you much better than I can, because I tried hard enough. But there's draft between, as you'll hear later on, there's air coming up between the plasterboard and the walls, as is the case in most houses built like this. So that wouldn't have made a big difference. And the other thing I have is an open fireplace. And I use that a lot for Bush TV, for my mental health, as we used to call it. There's something to stare at when you calm down. But open fires are really wasteful. They burn a lot of wood. They don't give you very little heat. And when they're off, they're really cold. And it's really quite difficult to seal off the huge draft they get. So what I wanted is an easy green heating system. And I wanted to be able to use the wood fire for heating. And that meant I needed to go for a wood stove with a back boiler. And I also, and this was part of the reason I ended up designing it, I also wanted the wood stove as a backup in case of power cuts. So that system in itself had to be power free. Basically, heating system is like this. You have a bunch of heat inputs and you have some heat outputs. And the heat inputs are typically either a gas stove or a gas boiler or an air source heat pump, or in this case, the wood stove. And then on the outputs, you have 2 outputs. Basically, one of them is domestic hot water, the showers, bath, and kitchen. And the other one is either radiators or underfloor heating, in the case of a water-based system, which is most common. Then in the middle, you can either have a direct pipe connection between your gas boiler, for instance, and the central heating, or you can have buffer tanks. That's the whole separate conversation, which can easily fill 15 or 20 minutes. And then I had solar on the roof already, and if you get that energy, you might as well tie it in. Now, what determines the design is this. It's the temperatures of what goes in, because a stove or a gas boiler comes in at between 60 and 95 degrees. An air source heat pump comes in at between 30 and 50 degrees. What you want to take out is, for hot water, is about 60 degrees. That's the barrier you need to get over to get rid of your Legionella infections, so you don't have to achieve that constantly, but you need to be able to reach that. And of course, for radiators and underfloor heating, you only need 25 to 50 degrees, and 50 is already on the high side if you want to keep it cheap. And then again, the buffer tank comes in. Now, at this point, of course, if you have these different temperature ranges, then some kind of storage tank becomes quite relevant because you can't mix the high temperature with the low temperature heat pump. Now, the actual design, I won't go into the detail, but maybe in the Q&A we'll come into that, looks a little bit like this. And if each yellow box is kind of a collection of valves and sensors in order to control the thing. And then, of course, you have a computer in the air source heat pump, which runs it all. So just imagine the first picture. That's much easier to understand. So my first approach was the commercial route, have someone install it, because I had an understanding of what heat pumps do, but that doesn't necessarily mean that you know what's involved in getting them to work. In the whole Northeast, I found 2 installers who were potentially able to do it, and within 6 to 12 months. Now, of course, this was before the winter, so that meant next summer, which wasn't that attractive, but was still an option. They didn't want to build in a wood stove system. They didn't want to build in any other connection. And one of them had their preferred choice of air source heat pump, and one of them was prepared to do a redesign for a different type, but at additional cost. Effectively, I got one quote of £13,000, which excluded any changes to the heating system, which I thought was quite high because the heat pump itself is only £2,000, that order of magnitude. And from that quote, it's pretty much plug it in and put a boiler in place. Now, I'm simplifying it a little bit, but we'll see what it comes out to. Now, the boiler stove, the chimney liner, I tried to get someone to help me with that, and I couldn't find anybody, any stove installer who was prepared to do anything that was kind of complex and involved design work. And I did get one quote for actually demolishing the chimney breast because I needed to move a small wood fire and I needed a big alcove for the wood burner. And they gave me a £5,000 quote for increasing the size of that hole. Now, I knew a builder who I asked about this, and he said, I bet you we can do that in less than a day. And we, in fact, did. So I saved myself a lot of money. I didn't really have that to spend on something trivial like that. But it did reinforce my idea that not all the professionals are on your side necessarily, to put it mildly. Okay, so what are the considerations for doing a DIY? One of the downsides is that you can't get a government grant. You need an MCS installation in order to get a government grant. So you have to make sure that you make it more cheaper than the government grant you're going to get. That's not English, but you understand what I mean. You also have to be really careful that you don't forsake the warranties that come with the equipment, specifically with the heat pump. And that's one of the reasons why in the design, I had to stick exactly to the specifications of the manufacturer. If you're an MCS installer, then you can design, you can change the pipe diameters a little bit depending on the installation. But in my case, I had no comeback to the installers, so I had to do that with the heat pump manufacturer. And the first thing they'll say, and I know this because I've been on that side, not for heat pumps, but for other machinery. The first thing they'll say is, okay, well, this is what the installation manual says. What did you do? And as soon as there's any difference, then they say, oh, yeah, sorry. So that meant additional work. And an uncertainty about doing it myself was I wasn't sure if I was going to come across any building regulations that I hadn't anticipated, which would either invalidate the whole installation or would give me some other problem in the future. Because, I mean, I can do all the technical stuff, but I don't know very much about building regulations. At least I didn't at that time. Okay, on the plus side, I can do plumbing. I've done central heating systems before. I can do electrical installations and building. I'm not certified in any of this stuff, but I can do it, and I can design, and I can read manuals and specifications, and I'm very familiar with high pressure and low pressure, high temperature and liquid systems from gas plants and gas installations, which I've worked with for over 25 years. So I'm not concerned about the safety of the final device. In fact, if anything, then I'm probably building more safeties just because I started off as a drilling engineer, and drilling engineers are always double, triple backups. So I had some time and not too much money, so I'd rather spend the money on doing it right myself than on someone else. And yeah, my experience with installers delivering quality or understanding what they were doing was pretty limited. In fact, I'd met quite a few who didn't know what they were doing. So I won't go into too much detail, but I ordered the water tank for the central bit, and that turned out to be a really expensive part of the installation, much to my surprise. And part of that was because of the specification I needed, and there's a very limited number available. And this one in particular is quite a common one, but it has to come from Finland, which takes a bit of effort. It's also quite big, had to go in through the window, so it's an extra £1,000 to get a company in to lift it up high and stick it horizontally through a window. I ordered the heat pump. I went for Samsung because that at that time was the quietest one, and my installation would be on the drive, which is open to the neighbor's front door and a window, a side window of the neighbor's living room. So that for me was kind of important. And the wood stove and the boiler I ordered together with chimney liners and all sorts of other stuff from a great company who actually know their stuff, helped me out in screening my designs for the boiler and stove safety. And I got a pretty good offer because I got an end-of-line high efficiency wood burner. And then I ordered a bunch of large diameter copper pipes because you need lots of them. Oh, just the water tank thing. On the left hand, you see my old water tank, and this is pretty much to scale. On the right hand, you see the new water tank. So the old water tank, 75 liters, the new one is 300 and split in 2 levels. To give you an idea, on the left, top left, you see what the old fireplace looked like after I stripped it off. And the outline is the hole that needed to go into that place. The bottom left, you see the current installation of the heat pump, which is on my drive. The box next to the heat pump is where the valve manifolds are. That's basically a cement box from the leftovers from my stove installation, because I had those panels and they were just big enough to make a nice box around that to keep the ice and snow off and keep it warmer. You see the big the cylinder in the middle. That's with about half the pipe work that goes into it. And this is, I made sure that I had enough space to actually be able to connect it up afterwards, because obviously it's new to me. So I didn't want to have forgotten something and have to take everything off again. The bits on the right are the unexpected stuff, but it is kind of expected. That's the current central heating system under the floors in the first floor. So I had to take the floors off there for some sections because that was the connection between the heat store and the heat pumps and the rest of the heating system. So they all had to be brought up to the bigger diameter. So basically all those pipes I had to replace and reconnect to the rest of the central heating system, which was quite a messy job. So the costs. Stove itself is about £5,000 altogether, including the chimney upgrade. The water tank with the equipment that goes with it was just under £5,000. Just over half of that is the actual tank. The heat pump itself plus the controller was just under 3,000. The plumbing, that's pumps and control valves and all sorts of things, safety systems, was another 3,000. And then I upgraded I upgraded 5 radiators for just over £1,000. And then there's another £1,000 of building material. So the whole thing, excluding my labor, came to £18,000. But of course, if you don't have the stove and therefore you don't need this type of tank, then you take £10,000 off that. And you end up with, I would have ended up with roughly £8,000, but I don't need a lot of the safety system. So it ends up substantially cheaper. Some of the challenges, I won't touch on all of them, but design challenges, one of the biggest one I had was that the specifications of the equipment are not in enough detail for an outsider to understand. There's a lot of assumptions that builders and installers have, which are based on using kind of standard setups for standard situations. But if you really need to find out which valve can take flow from both directions or only from a single directions, and which ones are hold pressure and to which pressure they do and when they release it. And all of those things are really important for both the safety systems and for the efficiency of your heat pump, because you don't want to accidentally have water circulating in a place where it doesn't help you. The other thing in the design stage that was important was understanding how I will use this new installation, because it's different from what I had. In fact, over the winter, I spent so much time in a really cold house that anything would have been better than what I had then. and working out how you would prefer to use the insulation, how you will use it in the summer and the winter was quite complex. On the installation itself, one of the things that cost me a lot of time was the routing of all these pipes in order to make it understandable. Because if you just connect the pipes the way they're on the drawing and you come back, a day later, then you can't understand how it works anymore. And I wanted it to be able to walk up to there. And as long as you understand what the system is supposed to do that. And that takes a lot more effort than I thought. And I spent quite some time studying the building regulations on the stove and the chimney, because that whole operation, even though in Scotland you're allowed to do that yourself, you also have to sign off that you followed the up-to-date building regulations. And I needed to make sure that that was exactly what I was doing. And there's quite a few building regulations involved in chimneys and heat and things like that. On the operation, the biggest challenges were twofold. One of them is the Samsung manual. And I heard from the head of the Samsung support department. He said he's been working with it for 5 years, and he said, yeah, he now understands most of it, but he reckons that it was an old style Google translation from Korean. And it did read like that. So it was to take engineering language and then kind of stick that through a manual machine. That's pretty much what it sounded like. And the other thing that you come across in the operation are the limits of the controller, not of the heat pump. I know what the heat pump can do. I know what it should be able to do. But to actually get the right parts of the controller to do that is really challenging. And thankfully, the Samsung controller is actually better than, for example, the Valent controller, which has more parameters. So in standard situations, it has a bigger variety of settings. But as soon as you go off the standard settings, then you have little choice. And yeah, it took a bit of kind of creative engineering to get through that. So how's it doing? Sorry, I'm at my time. My energy cost is exactly what it was before. And if you look at this graph at the bottom right, because I have an energy tariff and I didn't have individual monitoring at the time, it kind of averages over time, but it was an average of £200 a month on gas and electrics. And then it went up to about £500 per month when I was using direct electric heating over the winter when it was really very cold and horrible. And that didn't get the house warm, just to be clear on that. And then it went back down to slightly less than £200 a month with the heat pump and with the house that is much more comfortable than it was. It's a much more pleasant temperature. It's controllable. It's understandable. And of course, the emissions of my heating system went down to zero. The resilience is much improved because now if anything fails, I've still got a wood stove that can actually run the rest of the central heating system too. And that is separately battery operated. Not permanently, but as a backup. And the air quality in the house improved quite a lot. And that, I think, has very little to do with the heat pump. But what it did have to do with is the monitoring. Because once I installed the heat pump, I wanted to fine-tune it to find out what it was doing and what I needed. So I installed a number of temperature and humidity monitors throughout the house. So in the living room, the lounge, one upstairs in my son's bedroom, my bedroom, and then on the top floor to see how much heat was being lost through the room and roof. Relatively inexpensive with data loggers, and that means that you can see over the course of a week what your temperature range is, and then you can work out what you did and why that is a range to have, and to use that to adjust the system. And so that made a big difference. Monitoring the buffer tank temperatures, what you see on the bottom right, those are sensors which I installed in the buffer tank. It's a stratified water tank, as you can see very clearly now. Looking at that, I got an idea of how the temperature changed when I had my showers, and I thought that's really a large amount of heat that I lose in the shower. So I replaced the shower head with a low water shower head, which is actually more comfortable. And that made a massive difference on the heat loss. So again, the monitoring made me aware of that. And of course, I have power use monitoring for all the things, but that, you have to sit down seriously and take time to get all your data on the table. And I don't always have time for that. And I'm over time, so I'm going to skip the rest of the points. I'm just going to stick to the end, and that is that, well, heat pumps work. That should be obvious for most people coming here. That's very clear. They're cost break even when a house is not yet insulated, as mine isn't. So basically, yes, you can install a heat pump at any time. I would say keep it small, which I did specifically because once you insulate, you need a small heat pump rather than a big one. And for me, the wood stove helped me cover. I mean, I've had 3 days in the last 2 years that I needed the heat stove to get the living room up to temperature, which I don't think is bad going for cold winters. Now, for me, the next is to improve the insulation. But if you have the choice, then it's always better to start off with a full retrofit assessment that will give you an idea of what the house state is in and what you can do with it. And then probably to insulate. And I'd also suggest to use heating in the winter because without heating, it's pretty cold. On that note, I'd like to leave it. Thank you.